Hey everyone, this is a standard question from Stack's topic, which is called valid parenthesis. So we are given a string S and we have to check if, there the string input string is valid. How do we know that a string is valid? We every open bracket must be closed and they must be closed in the correct order. Yeah. So this is the question. So the intuition behind solving this question is that my last open bracket will be the first one to be closed. Why do I say that? Here my last open bracket is this. So this has to be the first one to be closed. Only then there's there's the string is valid. So in here we see that the last open bracket is this square bracket. So then it means that we have to first close this. So what's the data structure that works on this principle? Last in should be the first close. So last in, first out. So that's a stack. So the data structure we are going to use here is a stack. Of what? Of characters, right? And this will store our open brackets, or let's say ST is equal to new stack. Now what do? We need to process every character. So let's say that we iterate through every character one by one. So my character PH is going to iterate through S dot to character array. So now we have this for loop for each loop. And what do we do here is that there can be three cases. Case one, our current character is opening bracket. Okay. So if it's opening bracket of any sort, let's say case this or curly braces or even case square brackets, what do is we add it to the queue. We add it to the stack, stack dot push, and we add ch there, and then we break. Else, there can be three cases of is closing bracket, curly bracket, or a closing curly bracket, or a closing square bracket. So in all of these cases, we have to pop from the stack. So let's say character ch is equal to st dot pop. Now, first let's rename current. Current character is this. Now, there can be a case when there's nothing in the stack, since we're, seeing validity. So this, there will be the stack underflow. So we have to check if stack dot is empty. It means there was an underflow, right? So immediately return false here. Else, what do? We pop from the stack. And after we pop from the stack, we have to see if there's a matching. This, if we pop this from the stack, what is this? This is an opening curly bracket, right? So let's say opening bracket. Corresponding opening bracket is this. Or let's say last open bracket. Now we need a way. This is a closing bracket. We need a way to map a closing bracket to a corresponding opening bracket. So to do that, let's create a data structure or hash map, which will store character and character. So it will map a closing bracket to a corresponding opening bracket. So bracket map is equal to new hash map. So in bracket map, we have to put if my closing bracket is this, what's my corresponding opening bracket? It's this, correct? So same, we'll do this thrice. So yeah, now we do that for curly braces and we do that for square bracket. And yeah, so this is how my this looks like. So now we have to get a corresponding opening bracket, right? Corresponding opening bracket for my current character. So it will be my bracket map dot get ch. So now we have to check if these two match. If my last open bracket is not equal to corresponding opening bracket, what do we say? We say return false. So this is how it is. Yeah. Break is optional here since there will be no fall through. So yeah, this is the entire code, and S only consists of parentheses, so there's no need for other cases. So after we come out, we check if return if stack dot is empty. Why is empty? Because let's say there might be, opening brackets, like some opening brackets left which might not have been closed, something like this. So then we need to return false. So yeah, let's run this code and let's submit this. So coming to the time and space complexity, we are iterating through every character once. So our time complexity is big of n, where n is the length of the string, and our space complexity is, let's find out our space complexity. So in here we have this data structure called stack. So in the worst case, what will happen is my string could only consist of all the opening brackets and none of the brackets were closed, something of this sort. So my stack would then contain, let's say n is the length of the string. So my stack would contain n different, n different slots. So my space complexity will be big of n. And there's this thing called push and pop will basically take big O of one time, constant time. So yeah. So this is about time and space complexity. Thanks for watching. Bye.